Hi everyone, this is Aditya, and in this video I am going to give you a short demo on the platform PraxisTao. PraxisTao is made up of two words, Praxis and Tao. Praxis is an ancient Greek philosophy which means learn by practice, and Tao is an ancient Chinese philosophy which means the path. Now, combining these two, we create PraxisTao, which is the art of learning by practice by following your own path, whichever you want to follow. So, we are a complete AI first learning platform where we teach, not only teach, we provide end-to-end support for learning across different sectors in engineering, science, and business. Now, coming to the platform PraxisTao, we are different from the typical video-based courses like Coursera or Udemy, where there is a videos but people don't follow, and there are multiple simulator platforms like Wokwi or Tinkercad where it provides a lab to basically work on the simulation tools, giving real world feeling. But again, it is just a simulation tool and there is no learning. We are a complete AI first end-to-end platform where first we have like combined everything together, where we not only teach course, we provide end-to-end support from learning to building things to fixing to helping the users and providing them the best fee support so that they can learn the concept very easily. Now currently we have curated multiple courses. Currently there are 13 live courses on our platform, from business to computer networks to cyber security to electronics to machine learning to different segments of computer science, and there are many incoming uh, related to science, metallurgy, and different streams of engineering. What we are providing is not just a course, we are providing the complete end-to-end package like the electronic simulator tool where the user can come and simulate the whole thing without purchasing a single electronics component. There is a PCB design lab where they can design their own PCB. There is a coding lab where they can practice their coding learnings, and there is projects and labs to learn things by building real world projects. On the top of that, we are providing an AI tutor support. Currently, we are following a bring your own key model where they just need to bring your own key and they just need to paste it and save the key, and our AI tutor platform will be live. Now on this they can ask it any question and it will follow. What we are providing is not just a course, but we are providing learning from the first principle to visualization to simulation to building projects to the mastery of the concept, because learning is not just a one thing. It is a iterative learning, it is an iterative curve which the user need to follow. In the future, there is many courses which are coming related to multiple domains like mathematics, chemistry, aerospace, thermodynamics, astrophysics, robotics, material science, fluid dynamics, signal processing, quantum computing, and computer architecture. Now, coming to the platform, let's go on and see how courses work. In the courses segment, we can find currently 13 courses are live on our platform. On clicking any of the courses, we will find a list of chapters which the user can go and learn. What we have done is we have divided each of the course in multiple chapters, teaching things from the first principle, assuming the users know nothing about that concept to building a mastery in that concept. For example, in this demo, we will demonstrate how database and asynchronous system course in Golang works. The first chapter, the overview, deals with what things this course deals with, what we are going to build, what the user will see after completing the course, the learning outcome, how the chapters are divided, and how much complexity is required, and what level the courses currently deals. Now we can see the complete table of contents. Now let's go to any one chapter. For example, let's say asset transaction. Now in this chapter, let's say there is a concept where the user gets stuck. They can directly go to the AI tutor and they can just ask, hey, I am not able to understand asset principle, tell me what it is. And the AI tutor will just read the message. They have the context of the whole chapter. They will just go through it and create such a small and easy content which the user can just go through and they can learn. For example, in this case, I have asked like, what is acid principle, and I asked the AI to tell me them in the smallest possible way, like easiest possible way. And as we can see, the AI has given and broken down the concept in very small and easy to follow steps with real examples which the user can follow and understand. They have also provided the quick mental models to follow it, the simplest way to remember it, and everything. So this is how the AI tutor works with the courses. Now let's go to the other segments. Second segment is the simulator. Simulator is a complete electronic simulation platform. The problem currently we see is there are many colleges and schools in India which doesn't have the budget to have a lab, and due to that multiple students, millions of students in fact, are not able to learn by building, but they just learn the concept and they just follow that and just memorize it. They don't have any practice of it, and due to that we are seeing a real huge skill gap between the industrial knowledge and the things whatever is taught in the schools and colleges. And to fill that gap, the simulator tool is there. The user can come to the platform, they can create a new circuit. We currently supports the two boards, Arduino Uno and ESP32 DevKit. They can select any of the board, they can play around with the tool in the canvas, they can see the semantic diagram of the tool, they can see the diagrams and the connections of the tool. And let's say now they have selected any electronic component, like let's say potentiometer, they can do a real connection with the tool. And not only will it work, but it will also show the real example. So for example, let's say there is a servo and they want to make a connection from, let's say, first PWM pin to analog pin, and the connection is met, and in the left side we can see the real connections are being met. Similarly, they can do multiple connections and the semantic diagram of it will be there. They can click on the simulate button to simulate it, or they can export or save it. They can click on the serial monitor to see the outputs of the thing. Now in this demonstration we will show you some example circuits which we have rebuilt in our platform. For example, servo control motor, which is controlled by a potentiometer. So to run this project, they just need to click on the simulate button, and now when clicking on the potentiometer we can see the servo is being controlled. Similar to this example, there are multiple such examples like a button and LED connection. In this example, there is a push button. On clicking on the button, the light will glow, and to run that, they need to click on the simulate and click on the button. And as we can see, once we click on the button, the light goes on, and once we remove it, the light goes off. They can also stop the simulator and see the semantic sketch of this. They can either download it and do the real connection. So this is how everything works. Now not only this, they can also use the inbuilt AI support tutor to build it. For example, let's say here they want to do is, hey, build me a circuit where on clicking where where there are two buttons, and on clicking red button, red bulb close, and on clicking green button, green bulb close. And what this AI tutor will do, they will not just tell the user how to build the circuit, but they will give the complete diagram, the code, the sketch, and everything. So we just need to wait for this, and we can see it has given the complete thing. Now the user can either accept it or reject it, and once the user has accepted it, we can see the whole connection is created. Now the user can play around with this connection, and they can just simulate it and work on this, or they can write their own code, and if the circuit is not working, they can ask the AI tutor to help them debug the circuit. So this is how the whole simulation tool works for the electronics part. Now coming to PCB lab, PCB is a very important component in today's electronics, and there is very few softwares which provide support to build PCB, but we are currently providing that. Similar to electronics lab, they can just go and start from a blank board and create a connection, or they can just go and use the existing example boards. For example, let's say for this example we are taking 555 a stable timer board. Now in this board, as we can see, there is already few connections which is already created, and on the top of that, let's say if they want to build something, they can just select it and leave it, drop it here. To route it, they can just use the route, they can select the wire size, whatever they want to select, and they can make the real connection from whatever they want to do. It works like a real PCB simulator. They can either export the diagram in KiCad PCB format or a SVG format. For example, here I have downloaded it in a SVG format, and we can see the SVG format of that PCB tool is already there. Now coming to code labs, it is similar to how the other simulator tools and labs currently work on our platform. So currently in code labs, we provide support to multiple different languages, from front-end level languages to the back-end language like Express Server or other programming languages like Rust or Golang. So in this demonstration, we can select a quick template. So for example, let's say I will use the existing template, which is a Go-based template where some dummy code is already written. I can just click on the run, and we can see the output it will keep, and we can see the hello world output is already there. Now they can also use the AI tutor along with it. Same way, they can just provide the key and it should start to work. So here I will just say write code to detect let's say prime or not in Golang, and the AI tutor will work on it. And as you can see, it has provided the whole code to check if the number is prime number or not. Even it has given the function example, like we can directly just copy the function, we can just paste it here in our code, and we can use it in our main function. For example, let's say here is the numbers list, we can just copy it, and after hello world we will just paste it and just change the name of the function to this. Close the AI, and when on running we can see the output which we got from this. So this is how AI first learning helps. AI is not only just empowering the user to learn more things, but also helping them to understand things real quickly. Same way as we have created a new thing, they can AI tutor also helps them to basically debug things and understand what problems currently the platform has and how they can basically fix it. Similar to code labs, we have projects. Projects are a very interesting things in our PraxisTao platform, where we have currently curated multiple projects, and on the top of that we have a package manager which we have created to deal with the projects. So currently we support building projects in their local system, because in local systems there are supports to the database and everything which we currently don't provide, and in the future upcoming releases we will be providing that. So for now they can just install this package, and this package helps the user to basically create the projects in the local system. For example, as you can see, currently there are like 8 projects in our platform. Let's select any project. So first the user has to connect their GitHub, and let's say once the user has connected their GitHub, the project will open up. As we can see, the task currently completion rate is 0 out of 10, so the user had not completed any of the tasks. And what they need to do is, on starting the project, they first need to run this command lncli init project and the project name, and it will initialize the whole project in their local system. Post that, they can just go to that particular repository and they can just run the lncli command. What lncli command runs is does is it checks the output, like the uh, how what is the output of the code which the user has written to the test cases which we have currently curated for the user for this project. And if it passes, the user passes the test and moves on to the next project, next task. Or if it is wrong, then it tells the user to basically retry it until it is correct. If they have any problem, we have the hints provided in our thing, in our like UI, and the user can just understand the hint, or they can either use our AI tutor to understand it and build the project. In this way, we currently provide everything from learning to simulation to designing to coding to projects, and complete end-to-end platform, so that you don't need any big high infrastructure lab. You just need a laptop or a computer and a browser, and even sitting in the remotest part of country, you can just build projects whatever you want. You can learn whatever you want, and this is the goal of PraxisTao, to empower the people of the country to move forward and learn new things and build for the country without being restricted by the geography or the access or the financial condition. Thank you. That's it for this video.